Okay, for today, it's the first review day for the semester one final for honors higher algebra. And today we're going to try to cover chapter 2 and 3. Now, we won't cover everything. And what I'm going to do is your assignment is to do the evens. I am not going to do the evens for you. There's not that many evens. If I do all of them all hour, I will finish all the evens. So what I'm going to do is do some of the odd ones that you don't have to do, but I'm going to show you how they would be done. You really do want to pay attention to this because it's been a while. All right, instead start with an increasing and an increasing. You don't do this one, you're going to do that one, but I'm going to do A. You might want to write it down as an example for yourself, but increasing at an increasing, that's like this. It's steeper and steeper and steeper, okay? How you judge whether or not it's increasing or decreasing is as if it's rising or falling. How you judge the rate, if it's increasing at an increasing rate, it's steeper and steeper. So here it wasn't very steep. Here the steepness is much steeper. So if it's getting steeper, it's getting faster. So the notes I would have given you back then, do you remember me saying steeper is faster? All right. So it starts off increasing at an increasing, steeper and steeper, and then increasing at a constant. Okay, that's still increasing, isn't it? But see how it's at a straight line? And then constant, just the word constant means flat line. All right, and these are all distance and time. All right, and you are doing even problems and even letters, so you're going to do B there. Go down to number 2. Increasing at a decreasing. You'll have to go increasing, like go from here to here, but at a decreasing rate. So it has to go slower and slower. Starts fast, starts steep, gets slower and slower. All right. Okay. Here. Sorry, having technical issues here. There we go. Okay. So you guys are assigned problem number 2, right? Even problems and even letters. So you got to do all of number 2. All right. So what is happening in these spots? Well, just got to look at it and determine. Height's going up here, right? Height is getting higher and higher and higher in this little zone. So if the height's getting higher and higher, well, water's going into the tub, basically, right? All right. And there's different speeds at which the water can be going in the tub or going out of the tub. All right, I think those will be pretty easy for you. Let's go down to number 3. Just for help, I'm going to do some of the odd numbers or letters. Your assignment is even letters, so you'd have to do B and D and F, but I'm going to do like F of 0. Remember on this kind, they've either given me X or they've given me Y. If they say F of 0, did they give me X or did they give me Y? They give me X. X is 0. So if X is 0, I go on here. This is where the X's are, right? And I find, where is X 0? Oh, X is 0 right here. I follow it up to the graph. Boom, hits right there. So what's the answer? 1. All right. So if they're giving you an X, you find it along here. But look at letter F. You guys have to do number F. I'll help you with it. X, when F of X is 4. They didn't give you X, did they? They give you Y. They give you Y as 4. So then you go up to 4, which is here, and you go across on that line and say, where is it? Oh, it hits right there. And hopefully you know the other part of it. We already know the Y of it is 4. So obviously you need to know the X of it. All right. So what about the more complicated kind, like the ones that have multiple things? Well, just figure these out separately. Figure out F of 1, figure out F of negative 2, and that add them together. Just do it one at a time, and they told you X's on those. Here you can actually do these first, and anything in parentheses can be done first. So 5 minus 5 and a negative 2 makes positive 3, so it's a really F of 3. Okay, good enough on that. Let's move down. Clearing the ink again to this kind. Do you remember doing F of or G of numbers? Okay, it's pretty easy. You just take the number and stick it in. So this tells me to use the G function and stick a negative 1 in it. So I stick a negative 1 there, and I work it out, and it's got an absolute value when it's done. So remember to make it absolute valued, so it'll be positive whatever. That's all there is to that kind. For number 4, it's even problems and even letters. This is the all and even problems. You need to do all of those. All right. You know what? This is probably enough practice on this. You can skip these last couple. Those are pretty easy, and I don't need you to do that many of them. So you can skip those bottom two of number 4. Okay, let's move on to a different kind. This is the same idea. I think we can skip this whole page of them. Not necessarily the whole page, but all of these top ones, all of those you can skip, because that's too easy for you. There'll be plenty of hard stuff to remember. That stuff's easy. Just stick a number in a function. All right, but that one, x when k of x is 8, say that was on the final right now. How would you be thinking this through? X when k of x is 8. They gave you y, right, is 8. So I have to find the k function, and every other function doesn't matter. I'll zero in on this one. And what do I put where? 8 goes in for y, which is like k of x. So 8 goes in here. So that's an equation. And it's an equation that has an x minus 4 on the bottom of it. That's kind of a pain. How do you clear fractions? Times by, not the top, times by the bottom. So we times both sides by x minus 4. And then you'd solve from there. Yep, because it's an equation. I can't just multiply the right side by x minus 4. I have to multiply the left side by x minus 4 also. You multiply by the denominator. That's this part on both sides of the equation. Yes. 8, it's not really, it's called distributing, but, and the x minus 4 on this side would cancel that one, so it's just equal to 2. 8x minus 32 equals 2. Yep. From there, it should be nice and easy. Okay. I think that's enough for this page. Let's move on to this kind. Tables. These are easy. Honestly, you will dream for this kind of problem on the final. This is a piece of cake. There's plenty of hard questions. These are easy. Enjoy them. Okay. F of negative 1. So I just got to find where f function is. Apparently that's this row of negative 1. Apparently that's this row. And where do they overlap? 2. It just must be 2. Okay, you guys are doing even problems and even letters, so you guys do B, which is a lot like that, and D. Now, on a problem like D, look at D as in dog. Get how it has something inside of something? When you are in math class, you always start on the inside on hard problems like that. You start on the inside and work your way out, kind of like an alien that's infested a human body. They always start on the inside and then work their way out. Okay, anyway. So you start with the f of negative 1, and then we'll finish that, and then we'll go to the outside. What's f of negative 1? Well, I go to the f function and the negative 1, and I see where they overlap. Piece of cake. Now I just do g of that. All right. There are so many tables in the real world, that's actually a ridiculous question. In the newspaper, more tables than anything else. Like, they give you tons of tables to get info from. They do graphs a lot in the newspaper too, or in, online, like at time.com or CNN or wherever you get your news from. But tables are used a lot. You have to handle tables. Okay, so now let's go to the other worksheet. That was the basics review, chapter 2. You have a question first? Okay, all right. Sorry, I thought you said you had a question. All right, so let's move to, that was unit 2. How about we get through unit 3 also? And remember, your assignment is to do unit 2 and unit 3, even problems, even letters. All right, now I know there's a zillion things in here, but we're not doing all of that. Remember, what are the puzzle pieces? Okay, those are the quizzes that come from that, that are from that unit. And again, we won't hurt your grade for taking them for practice, but you don't have to. What you have to do is go through and find the worksheets, which are, let's see, this one and this one, stretches and shrinks. This one unit is actually like 2 or 3 tests, isn't it? And Circles is like one problem, so I won't even assign circles today. But anyway, we'll just do those two, and I'm hoping that they're come back to you really easily. Because honestly, we did so much with like moving to the right, moving to the left, that kind of stuff. I think these are going to be really easy for you.
Oh, this is like -2.
Yep, if it's -2 on the inside, it's right 2, that kind of stuff. All right.
Oh, then
Good.
if there's like a negative in front, then it's like a flip.
Yep, if negative in front's a flip, that kind of stuff. All right, so let's do even problems, even letters. So this is on number 1. We're going to do B as part of your homework and D, etc. Okay, I will actually, since there's more worksheets than I thought there were, I'll do some of the ones that I'm assigning you also. Okay, so be on this worksheet with me. Would you please, I'm going to pause for a second, turn it my way and show me that you have got this same thing. Okay, there we go, back again. Let's do B as in baloney. It's reflected across the x-axis. Do you remember what's that little thing we put on there?
There's gonna be a high low.
Yes, there's high VO involved, absolutely. So y equals, let's say it was like this. If it's inside, horizontal on the inside, changes, and the changes on the outside, whether it's here or here, those are VOs, which stands for what? Vertical on the outside. Okay, good. So in this case, is it a high or a VO? All right. So it's a vertical on the outside, you're saying. All right. So it says reflected across the x-axis. I'm going to picture what that looks like. This is the x-axis. It's going up and down. Okay, that is a vertical thing, isn't it? So it's a VO. Good. So it's y equals x squared, but I got to do something on the outside. What do I do on the outside? A negative. Good. And so many people asked me in the past, it seems like such a silly question. To me, I just don't understand it, but they say, is that on the inside? The only way it would be on the inside is if there's a parentheses that makes it be on the inside. You can't be on the inside unless there's some kind of a grouping symbol, like a parenthesis or a square root, and you're in there. That's how it's on the inside, is if there's parentheses. If there's no parentheses, you can't be on the inside. Okay. All right. The only exception to that I can think of is this. Do you get how that -4 is on the inside, even though there's no parentheses? But do you remember me saying that if you have a big fraction like this, you actually have parentheses there that you just can't see? It's true. Big fractions cause you to have a grouping symbol. So bottom line is, things that are on the inside will have parentheses or a parentheses that are kind of implied. Yes, the reflection is what makes you have the negative. All right. So y equals -x squared, and then translated 2 to the right. Oh, I need an inside. Now I've got an inside. And then 2 to the right is -2. And then 5 down. How do I do that? -5 on the outside. Piece of cake. All right. I think these will be easy for you. Stuff on the inside, remember, it's always counterintuitive. -2 seems like it should be moving left, but it goes to the right. Things that are on the inside are opposite of what you'd expect. It says down. All right. So, moving on to the next kind of problems. In problem 2 here, you're doing even problems and even letters. This is an even problem. So theoretically, you should do all of these. You know, now that I'm seeing how many problems there are, I'm okay with you doing even problems and even letters through the entire assignment, meaning you only have to do the even letters on the even problems. You know what I'm saying? So we're only doing B and C. No, not C. B and D. Those are the even letters. Okay, so you're going to do those two. Do you remember how to take a squiggly shape like this and move it around? First of all, its equation is f of x. If we don't know what it is, we put an f. You could say, I'm not sure what, I'm not going to say it. That'd probably be naughty. But anyway, I don't know what the function is, so I'll use an f. Okay, anyway, so f of x has to be moved somewhere. Well, if this guy is the original right here, then do you get this guy has been moved down? And then I'd pick a spot like maybe this and see how far did that get moved down. And you look over here for that same spot. And now I can compare them and I go, oh, it got moved down 2, -2, like that. So you're writing me a function that has f of x in it. Okay. Hoping this all feels fairly easy. Notice in this, problem 3, it says skip this section. Yay, you can skip that section. We never covered ones where we said y is replaced with y minus 6. We didn't mess like that. So you may skip that whole section that says skip this section. All right, moving on, different kinds. These are the absolute values. All it is a different parent. Remember what shape absolute value is? A V. Good. Let's review all those shapes right here. Just a second, please. Delete that. This is the absolute value one. This is a parabola one. This is a square root that's got flipped. Remember the parent square root kind of looks like that? So that's y equals the square root of x. Somebody was asking about the butterfly earlier. Remember that one? 1 over x. And it looks like this. Remember that one? That's the butterfly one. Now, what about a straight line? Y equals x. But it might be stretched or it might be moved, but that's a straight line. Specifically, that's this straight line. And then what if I want to tilt that thing so it's kind of like this one? If I want to tilt it, I got to change its slope. The slope is how it gets tilted. And this dotted line that I just drew on there, that's a line that's going through y equals mx plus b form. And it's going through this spot right here. See this dotted line? And that's the y-intercept is -1, so I'd put a -1 right there. And then what's the slope on it? Slope is rise over run. How much rise, how much run? Rise isn't actually rise. It's rise of -2. Because as you read from left to right, it's going down. See? Down. So that's rise of -2 and run. Run always has to be positive. You always go to the right on these. So that'll always be a positive number. So there's my slope, and it's touched its y-intercept, which is I should put right here. Its y-intercept was -1 or -1. No, I didn't talk about that at all. I just said if it's a straight line, this is the slope. And yes, it looks kind of like a stretch factor, but it's different on a straight line. On a straight line, it's your slope. Remember rise over run? So this is the rise, this is the run. Stretches are different. That's a whole different topic. We aren't there yet. That's a different worksheet. Okay, getting close. Not done yet. X cubed is one of the parents, yes. Let's see if there's one on here. There's not one on here, but you do have to know it for your test. X cubed is the one that looks like this. Yes. Calculators allowed on part and not on part. It'll have a, you know, you'll have one of the sections you'll say calcs allowed and one of the sections says no calcs allowed. You'll get one part first and nobody will have a calculator out. They'll finish that, then they'll turn it in, then they'll go back and they can do the other part with their calculator. Yes. There is, I think I can, yes, I know I can tell you now. It is finalized. We've made it all multiple choice this year. So, yes, yes. Now, you know that doesn't mean automatically easy because what we do is take the common mistake answers and they are there. It's not going to be like stupid answer, stupid answer, stupid answer, and then only the right one is the only one that's close. I know some are like that in the world you've had before, but this is going to have the common mistakes are these three things, so we'll put the common mistake answers and the right answer in there. So these are pretty well thought out multiple choice. So it's not, that doesn't mean easy. Probably does mean easier, I'll give you that. Okay, because I'd always rather see what my choices are, and if at least you can say this, if your choice isn't there, you think the answer is like 6, and it's not in the list, well, at least gives you some good information to have, right? Good question. This is graded as a simple straight percentage. It is not Marzano. If it was Marzano, all the questions would be harder. So in other words, for the honors pre-calc, for instance, when we do grade Marzano, every single question is like one of the challenge questions, like hard. So Marzano is definitely Nice to have that whole 75% is an A thing, but it also means the questions are harder. Okay, so move on to this. So if they have a squiggly looking thing, that red graph over on the left, then you're supposed to do these changes to it. What if they put a negative on the outside? What are you going to do to it? Flip over the x-axis. It's an up-down flip. It's a vertical flip, right? It's a vertical on the outside, so it's a vertical flip. So this point has to come up here. Now this point right here. And this point has to go down there. And this point is on the line, so how do I flip over the line if I'm on the line? It'll move, okay? So that stays the same, that's different, and that's up here. And then you connect your dots kind of like that. All right, so that is, if you start with a sawtooth graph, which is what we sometimes call these, the pointy, and you move them and stretch them and that kind of stuff. Oh, domain and range, haven't talked about that in a while. Domain is this way. How far does this go? Does it go forever in both directions? No, it ends. It goes kind of from -4 to 4, but you better be more careful. Does it actually touch at -4? No, so it's from -4 to 4, but it doesn't touch at -4. How do I do that? Parentheses. What if I'm touching at 4, like on the other end? See that empty circle? It's trying to make the point that on the left, empty circle means it's not touching there. Solid circle means it is touching right there. Do you get the difference between those two? Empty circles are, like you've seen this back to grade school when you were graphing like x is greater than 5. It looked like this. Empty circle means it's not 5. Filled in circle means it's 5 or bigger, and it could be 5. Okay, so if it can be something like a filled in circle there, then it can be that, so you put a bracket on it. All right, so that's domain and range. Range, okay, range goes the other way. So range goes this way. How low and how high? What's the lowest this thing goes? -3. Does it actually touch -3? So -3, parenthesis, to, how's the highest it goes? 2. Does it actually touch it 2? Yes, it does. Bracket. And if you can't tell, they'll make it really obvious if it doesn't touch something. If it looks like it's touching it, it's touching it. So it's touching there. So, all right, so that's domain and range. They just are opposite directions. One's left, right, one's up, down. I usually say that the range is down, up, because notice so many times kids have these written backwards, and it's wrong. The smaller number has to be on the left. Okay, don't distract people with questions. You can ask me questions, but I don't need anybody distracted. We're almost done. So that's -3 to 2. Can't reverse them. It has to start with the smaller number first. So any negative number, like, well, negative infinity is the smallest number of them all, would have to be on the left. All right, so then that's the end of that worksheet. Let's get the other one. Will be our last thing we have to do for today. And I know there's lots of problems here, but I remember I'm cutting a bunch out. Stretches and shrinks, final review. That's the part where we started throwing in numbers in front. Somebody had asked about stretches before, and now would be a good time to talk about those. So, on the stretches and shrinks worksheet, even problems, even letters. So problem number 2, you're going to do you remember the square root function kind of looks like this, over 2, or over 1 up 1, over 4 up 2, over 9 up 3. Does that ring a bell? That's the square root function, except this square root has had a couple things happen to it. Now, I told you before that on graphing that an XY chart is your best friend, because once you try to flip this and stretch this and it gets really confusing, you can be sometimes really confused on where should the dots be. I'll try to do it once, but then I will check it with my XY chart. That's what I'm saying. Okay, this on the outside is an up-down flip. That means basically it goes something like that. You get how the green one is an up-down flip, a vertical flip? It went that way, vertically, see? And then, what's that 1/2 on the inside doing? Well, it's a half. It seems like it should be half as wide. But why is it lying? It's on the inside, so it's not half as wide. It's twice as wide. Okay, so if it's twice as wide, how do I do that? Well, I take the dots. There's a dot. Oops. Hold on a second. There's a dot here. There's a dot here. There's a dot there. And there's a dot there. I take those dots and I make them twice as wide. So how wide is this dot? It's from here to here. I'm going to make it twice as wide. I'm going to move it over to there. How wide's this dot? That dot's 4 over. I want it to be twice as wide. 8 over. And now, there. I know that's not very satisfying. When you have stretches and shrinks horizontally, they can be difficult to see. But here's where it used to be, and it's gotten stretched wider. It's like you grabbed the lower one with your hand, and you grabbed and dragged it that way. It would stretch out to be the upper one. Okay, now, how do I know if I'm right? I check myself before you wreck yourself. So if you put in just any number, that's not smart. You want to put in strategically chosen numbers. Like, what's easy to take a half of? 2. So I stick in a 2. 1/2 of 2 is 1, and the square root of 1 is 1, and then it's negative, so it's -1. Is 2 comma -1 on my graph? Yes, it is. It's a little messy, but it is. Okay, now let's try another one that works nice. Say I put in 4 here. I can do half of 4, but then I'm going to have to do the square root of 2. I don't want to do 4 then. 8, I agree. So if I put in 1/2 of 8, I'm going to get 4. Square root of 4 is 2. Then I make it negative. So putting in 8 gave me -2. 8 comma -2. And that's on my line 2. I can tell I did it right. So please check yourself on your graphing. They should be the easy points on the test. If you take an extra minute to double check it with an XY chart. All right, we are almost done. And let's say that you just have your typical, here's typical ones I think you're going to be fine at. But what if they do something like this, number 8? Given y equals f of x, does that really mean much? Y is f of x, isn't it? Equals x squared. Oh, I know what that is. It's just a parabola, right? So the whole line just means a parabola. If that's a parabola, then I'm supposed to graph that. What's f? F is the function. They're just saying, take your parabola and do that. What is it telling you to do? 1/3 on the inside makes it 3 times wider. 1/2 on the outside makes it half as tall. So you could call it a vertical shrink. Okay, good. So you take your parabola and you all the points of that one, over 2 up 4, over 1 up 1, over 2 up 4. There's all my points, and I could actually do those things, make them 3 times wider than they were. Like this point moves over to here because that's 3 times as wide as it used to be. And this point would move over to here, 3 times as wide as it used to be. And basically, I'm going to have a stretched out parabola. And then that 1/2 on the outside makes it half as tall. So I got to cut all the heights down half as big. So like it ends up really open and stretched out, kind of like that. Yes?
So it's not like you take the x squared and the top one and square the
I don't know what you mean. Try that again.
f of x equals x squared.
Yes, that's telling you you've got a parabola. And this is telling you what to do to the parabola. Okay. All right, that's all the tips I have for you for today. Remember, there's a key there too. Do it, check it. I'll get the tests at the door from you as you leave. That's all I got for today.